Okay, so grading an exit slip. Make sure you have actually done the exit slip first, alright? Done your best before you actually grade it. Alright, and be honest, don't just copy. Alright, so number one, diagram describe what happens to the particles in a substance when it freezes. So if we're freezing, that means we're going from liquid to solid. So a liquid will move some, but not a lot. Right, and it does not fill its container. So a liquid would move a little, right, but it's still kind of together. It's still pretty close, but it is moving some. Whereas a solid, right, has a set shape and really doesn't move very much. If anything, just kind of vibrates like that. It says also describe what happens in a substance when it freezes. So what happens? Let me see if I can actually just do a different text box here. So I'm going to do it down here and then move it. So when a substance freezes, the energy is, so let's see, does energy have to go in or out? Well, if it's freezing, it's losing energy because the solid has less energy. Energy is removed. And so the kinetic energy decreases, the particles move slower, and are less, or not less, more actually, because they're moving slower, are more attracted to each other. Okay, so just on this one, I would probably do a check for the drawing here for liquid, a check for solid, and then here I would look for at least two of these three probably. Energy's removed, that could be a check. Kinetic energy decreases, particles move slower, more attracted to each other. I'd look for, a good chunk of these, alright? It just kind of depends on how well people use them as far as the exact whether you get credit or not. But if you want to be safe, just describe all of it and there you go. So that's my recommendation. Number two, if 15 grams of water freezes, how much energy is released? So we're given 15 grams of water, that's M. It's asking for how much energy, so that's Q. And it says, how did you know which equation to use? Okay, well, this is a phase change, so we're going to use Q equals M delta H, because this is a phase change, not a temperature change. Alright, so now I just plug this in. Q equals 15 grams. Oh shoot, what is delta H? So to figure that out, we have to look it up from our equation sheet, which I'll just grab this. This is from Unit 1, but it's the same equation sheet. So delta H, it should be fusion because it's freezing, so it's the opposite of melting. So we can use either one of these. I'll use the joules because that's mostly what we've been using here. So then delta H is going to be negative 334 joules per gram. Grams cancels. And so now we do 15 times 334, gives us 5,010, so equals 5,010 joules. Technically it's negative, but it's just asking for how much is released, so we would go just the total magnitude. 5,010 joules of energy is released. Alright, and that would be about 5 kilojoules because it's 5,000. Kilo means 1,000. Okay, so if I were to grade this here, I'd give one check for picking the right equation, Q equals M delta H. One check for the reasoning. This is a phase change. Check. One check for the work, 15 grams times 334 joules per gram. One check for the number, 5,010. That's a check. And one check for the unit, joules. Alright. And then if you use a negative here, you kind of have to write a sentence because it's just asking how much is released. Alright, so that's 4 here and 5 here, so you can put this in total out of 9, and then make sure that I get them so that I can see how we did, alright?